If you are watching this, I suspect you are serious about seeking a cleaner energy future. The key to that future involves creating practical means for energy storage. This is the core mission for ezNGSolutions. It is well known that the push for green power is increasing the need for natural gas, and we know that LNG will play a huge role for consumers generally wanting greener fuels. However, there is a real pressure to find cleaner alternatives because many people realize that LNG has a large carbon footprint. While ezNG can provide savings to a growing LNG market, we are excited that our technology opens the way for lower carbon fuels that are stored as cold pressurized liquids. One option is pressurized LNG, invented over 50 years ago as the sweet spot for liquefying gas for global transport. This graph shows how PLNG avoids the costly containment needed for high-pressure CNG on the right and the high energy needed to produce conventional LNG on the left. In fact, ExxonMobil reports that LNG requires twice as much energy as PLNG. But one might ask, if PLNG is so great, why hasn't it already displaced LNG? 25 years ago, ExxonMobil thought PLNG was attractive enough to spend tens of millions on it. Here's a summary of the key advantages Bowen reported in 2005. Pretty impressive, eh? So why did ExxonMobil drop the ball? Well, PLNG was competing against its own megascale projects, so the ship for this special project was designed with a very large capacity, and the cargo storage cylinders were a big problem. The special high-strength steel and welding required intense R&D efforts and would be very costly compared to common cryo steels. It was also challenging to secure them into the ship's double bottom. Further, tanks made of this material were unable to even store common LNG. Around 2005, the PLNG initiative was shelved. It is clear that ExxonMobil and the world needed a viable tank technology. With special steel and welding, as well as supports extending into the inner bottom, ExxonMobil's unique ships would have been expensive. It's easy to see how much smaller an ezNG ship would be. ExxonMobil's design also requires about 5,000 tons more very expensive steel. So each ezNG ship would cost about $150 million less, meaning big savings for projects needing fleets. And remember, ezNG ships can carry either PLNG or LNG. ezNG's patent allows pressures to be constrained by adjacent cells and surrounding structures. On land, cells can be secured within concrete vaults. Afloat, much larger cells can fill insulated cargo holds in ships or barges. Today, many ships are adopting LNG as a fuel. Note the costly complexity in this fuel tank that can only resist very low pressures. ezNG will start generating revenue through license fee agreements. Projects delivering gas by sea will generate tariffs. In due time, our venture will greatly increase cash flow by launching multiple shipping projects. ezNG will seek to lead projects and will be a strategic partner in others. ezNG cells will also be deployed into non-cryogenic projects where warmer temperatures allow the use of normal stills, cutting tank costs by a factor of 4. ezNG has a highly qualified team of leaders and advisors. The founders are respected professionals in the energy and marine industries. Our low-carbon future needs practical means for energy storage. And because PLNG is greener, simpler, and costs less than LNG, it provides a great opportunity, not a burden. ezNG is seeking strategic partners and major investment to drive this industry step change. The world wants LNG. Help us bring a greener LNG industry to the world.